west, and always above your head. Meaning what? Roof in this country is damn important. Roof, and roof, not wall. What do you see outside? Walls. Roofs are getting smaller and flatter. The reverse of theory. Okay? This is just to show you that, we are here, the sun is always above you, so the roof is very important. Yeah? But in other countries, they are slightly, tilted at certain angles, so walls become more prominent in terms of receiving sun or cutting sun from getting into your building. It's very simple understanding, but yet it has not been practiced. Right? So don't call me into your design critics if you're not doing it. Okay. You cannot find it in any book. This is just my summary of what I think what we should do. If it is wrong, I got a few aspects here. Please let me know so that I can change my slide later. First is that critical exposure to sun 10 to 4 p.m. maximum radiation on the roof. Yeah? Very simple. Why I come into this conclusion? You don't play soccer before 4, except in tournament. Yeah? Normally, if you have students will go down to the field at 6 o'clock. And they have to stop at 7 to field because of the grade. They don't dare to go before. It's too hot. Just imagine that your building is also the same thing. They are exposed to the sun, so they are feeling the same thing. It's just that they don't have human feeling just like us. Hot evening sun is about 4 to 5:50, and it is always west wall. And a lot of lecturers say west wall is very important for you to start thinking as a buffer. Okay? This is in relation to the position of the sun, and it is hotter on the west wall. But if you want to use solar irradiance falling on the surface, you should face to the east, because they receive longer time of solar radiation. So you just have to see which one is important to you, and how you orientate your objective to the understanding of the sun. Yeah? Higher total solar irradiation on the east wall. Right? So some people say, how should I orientate my solar panel? So if you use my principle, it's east. What's the east? Some engineers say west. So take the middle, the middle decision. Put it almost right, but leave it 10 degrees Celsius so that it's self-cleaning. So that's good enough, because most of the time our sun is above our head. Yeah? But the more efficient is actually tracking the sun angle. Lower sun angle is on the north and at 69 degrees Celsius, 69 degree angle. And lower sun angle midday in December you reach 63. So if you look at the slightly different angle, but if you want to do a modular system, just use the same angle, the angle that will cover both sides, south and north. Okay? But those is slightly different. Yeah? And then you actually save a lot of material if you do exactly to the penetration angle of the sun. And of course, very easy principle is to always think when you design a low-rise building like a house or terrace houses, not more than say 5 story. Okay, roof is the most critical. If you want to put insulation, put it on the roof. Yeah? But when you talk about high-rise building, of course, wall areas are bigger than the roof area. So treat the wall better than the roof. Okay. Alright, the objective is actually understanding the climate condition is for users' comfort. So these are the studies being done for tropical climate. This has not been revised lately because I think no one likes to do thermal comfort anymore. There is no thermal chamber available in this country that is operating well. These are some of the studies being done in tropical climate. So if you look at it, this is Malaysian who studied thermal comfort of Malaysian in UK. So they say 23 to 27 degrees Celsius. So if the government says put your air conditioning system 34, they are right. I mean, it's almost right. Huh? So don't go home and grab the remote control and 16 degrees Celsius. You cannot go lower. In this country, 16 degrees Celsius is the lowest that you can play with your remote. When I go back home, it is always 16. Because my children always put it 16. The belief is that the cooler the better, right? So there's a lot of awareness campaign in my house to actually make them understand that Climate-4 is good. Okay? And of course, I brought my tie, I didn't wear my tie, just to show to you that if I wish, I will not wear even this, then I will put my air conditioning system at 30 degrees Celsius. I'm still okay. Yeah? So the way we dress also have to change, because then you dress less, doesn't mean that you look alright. You dress less to save a lot of energy. So, spend money on handphone. Why not? Okay. Alright, and I have this chart when I did my undergraduate 30 over years ago. And I believe this is the most or the easiest to understand in order to teach my students about thermal comfort. So this is where we will feel comfortable. If you're not, you come in heat. If you feel too hot, you bring in some wind. Okay? As long as heat and wind can bring you back to the comfort zone you are in the most optimal condition. This is what we call comfort zone. Yeah? In our case, it will be between 20 to 30 degrees Celsius, and the humidity should be from 20 to about 80% relative humidity, but the best is between 50 to 65, so that you control that mold will not develop. Okay? That's why air conditioning system is good, because it reduces the humidity so that you can actually reduce mold growth. How many of you remember the case of Hospital Sultan Ismail in Johor? When they open, they cannot go in because the hospital is sick, not the people inside the hospital. Yeah? Because there's a lot of bacterial viruses due to the mold growth. And they blame, who do they blame? The landscape architects, because they have plants inside the center of the hospital. Well, they have to blame someone, or somebody in this case. But the idea is actually to manage our relative humidity inside our building, so that it will not develop mold and other not so good things. Alright. I hate teaching this to our architects because there's a lot of frustration out of this. So what I do is always, just remember which Q is very important for you that you can handle as an architect. If you cannot handle, just ignore it. Very easy. Yeah? We as architects, we look at what we can do. Okay? But if you cannot do, then call specialists. That's so simple, so easy. Don't be too smart of being a old paradigm of master builders. No more to, believe me. So you have to have a lot of backwork in order to really come up with a good design. So I'm good with Prof. Hamdan. So he gave me a few tips on how to actually recycle something or use herbal product. I don't know about anything about that, so have a good memory with him. Alright? You are not a master builder anymore. Don't believe in that concept. If architect tell you that, tell them I disagree with him. So we can have a debate on that. Anyway, QE is evaporative technique. Don't use it as a waste of money in this country, because the humidity is very high. I have done testing in my project in Johor Bahru. I spent 21,000 to crack temperature